into 4 equal groups, and they are marked with Q1, Q2, and Q3. If we draw a line with the lowest data value to the left and the highest data value to the right, we can mark Q1, Q2, and Q3 at equal distances on the line, with each section being 25%. Q1 is the same as the 25th percentile, Q2 is the same as the 50th percentile, and Q3 is the same as the 75th percentile. There is a fairly simple way to find the data values of a data set that correspond to Q1, Q2, and Q3. Using a data set from an earlier video, we first arrange the data in order of smallest to largest. Next, we find the median of the data values, which will be the value of Q2. Since we have an even number of values in the data set, 20, the median will be between the two middle values, value number 10 and value number 11, which are 15 and 16. Add them together and divide by 2, and we get 15.5 as the median, which is Q2. Next, we find the median for the values that fall below Q2, which will be the value of Q1. Since we have an even number of values in this section of the data set, 10, the median will be between the two middle values, value number 5 and value number 6, which are 9 and 10. Again, add them together and divide by 2, and we get 9.5 as the value of Q1. Next, we want to find the median values that fall above Q2, which will be the value of Q3. Again, we have an even number of values in this section of the data set, 10, so the median will be between the two middle values, value number 15 and value number 16, which are 21 and 23. Add them together and divide by 2, and we get 22, which is the value of Q3. Another concept that's important in regards to percentiles is the interquartile range, or IQR, which is the difference between the third and first quartiles, written as IQR equals Q3 minus Q1. So in our example, this would be 22 minus 9.5, which is 12.5 as the interquartile range for the data set. The interquartile range can be used as one way to identify possible outliers. An outlier is an extremely high or low data value compared with the other data values in the data set, and it can have a dramatic effect on the mean and standard deviation of a data set. For a visual reference, here is a dot plot, and you can see all of these values kind of bunched up together. But way over here to the right is this lone value, which just seems to be out of place, and it could possibly be an outlier. Maybe a researcher mistakenly marked this value or read the wrong number.